This conference will now be recorded.
Yes, it's being recorded. Okay, so I'm completely onto the 12 years onto the data side. Basically, I worked for a different MNC companies here in India, but I have never been to the abroad on any technical assignment, right? So basically, myself, I've been doing these trainings from last 4 years. And basically my strength is more onto the ETL, data modeling, PLSQL, and then database, all that. So that's pretty much about it. And I also do understand the different reporting tools like OBIE, Tableau, Cognos. I mean, a little bit of ClickView overview, and then some of the cloud BI tools as well. I know, right? So that's pretty much about myself. And as you guys really understand, right? So I'm going to specifically talk about today. I'll just give you the complete introduction, basically, which helps you to understand, what are you going to learn as part of this training, and I mean, what are all the things that you're going to learn, and how it helps you to get the job and all that, right? So that we will try to cover up, and I'll take from very the basic level of understanding so that you can correlate each and every term that we are actually speaking as part of this training to a you'll be able to correlate and understand the things very easily. Okay, so you guys are on mute. What I do is, I my style of teaching is like, I actually speak for 15-20 minutes, and then I'll open up you for your questions, and basically you can go for your questions. We will understand, and then we'll proceed further on that. Okay, so that's how I'm going to keep it up. So what I'm going to talk about in the first maybe the first 20 minutes, it's going to be, I'm going to talk about what is a database, right? Or maybe we will call this as, let's say, RDBMS, right? Relational Database Management System. What is RDBMS? And we'll also talk about, let's say, the different types of RDBMS. I mean, basically the different types of databases in our layman terms. Okay, and basically the different types of databases we will understand, and we will learn about, let's say, a basic thing on what is SQL. I mean, what is an SQL, and basically there are certain things which you need to also understand nowadays. There is no SQL as well. Without using SQL, you can also communicate with some of the databases. We will also understand that what is SQL and what is no SQL as well. And basically, I mean, once we are clear on the different databases and what is SQL, and then we will talk about, let's say, what is a data warehouse, right? What is data warehouse? And I mean, what is OLTP? I mean, what are the different transactional systems that we see on a day-to-day basis, right? What are the different transactional systems, what it is there? And what is the data warehouse? And what is ETL, right? ETL and the different ETL tools, and what is BI, and what are the different BI tools. And then we will, specifically talk about the, the job opportunities, how it is there for now on the ETL side. All that we will try to understand. I mean, there may be some of the terms we may not go in detail, but we eventually understand most of them basically by the end of this training, and that will really help you to get placed as well as attend interviews and all that, right? Okay, so let me get started. I mean, when the computer, I mean, if you can start from the generation of the computer started, people used to store the information in the form of floppies, CD drives, all that used to happen. I mean, when you start storing the data in the CD drive and all, or in Excel, basically searching for a data, it used to be the difficult, and then reading the data becomes very difficult, and relating the data from one Excel file to another Excel file becomes a complex and everything. So I mean, since storing the data in the files was a difficult thing, then they came up with a concept called as the database, which eventually in the technical terms we call it as a the relational database management system. RDBMS stands for a relational database management system, which is called as an RDBMS. So what is this RDBMS is all about? RDBMS is nothing but a product, I mean, just like a Windows operating system. I mean, it's just a product, Don't just compare again RDBMS as an OS. I mean, it's not an OS. It's a product which can be installed in any OS. I mean, whether it can be a Windows operating system, or it can be a Linux, or it can be the Unix. I mean, Mac probably it may not support, but most of the databases will not support, right? So relational database management system is nothing but a product. Okay, a product. This product, what it does is it actually stores the data in the form of tables. How does it store the data? I mean, I said in olden days we used to store in the form of files, books, and registers. I mean, before the computer generation has started, right? So it actually stores the data in tables. I mean, if you ask me what is a table, a table is nothing but which contains the columns and rows. I mean, if you look at an Excel, right, you'll have a columns and rows. I mean, this A, B, C, D, which represents here is a column, and 1, 2, 3, 4, whatever you have, that represents a row. I mean, it's basically the two-dimensional thing. I mean, where you represent the data in the form of columns and rows. I mean, suppose let's say if you're storing an employee information, let's say employee details in an organization, so this is how it actually stores. I mean, let's say first name, last name, and then the salary and all that, right? So when you say an employee number 100, let's say first name is going to be, let's say, Karthik, and let's say you have last name ready, and then the salary is, let's say, 56,000, something like this. So this is how it will start storing the data. I mean, let's say 101, and maybe a Kamrul, Islam, right? So basically, this is going to be, let's say, 80,000, something like that. So this is how the data is actually stored in a DBMS or an RDBMS. I mean, DBMS is database management system. I mean, it eventually the databases are termed as a relational database management system because, when you start storing the data, you'll have a different types of data, right? I mean, when I say different type of data, it's nothing but you may have employee data, or and you may have a department data as well. So which is nothing but your department number, department name, let's say one, administration, right? And two, human resource, right? So likewise, you'll have a different types of data, right? So basically, when you have a data which is stored in the different tables, RDBMS is nothing but we actually relate one table to another table. We'll relate one table to another table. That's why DBMS has evolved as an RDBMS, because the relationship exists between a one table to another table. See, suppose let's say if I have to understand whether this employee belongs to which department, right? So this employee belongs to which department. So basically, we can actually start storing these employees with a particular department, right? So maybe these employees belongs to IT, so we call them as, let's say, they belongs to this one. So why it is termed as an RDBMS is because there will be a relationship which exists between one table to another table. That's why we call it as an RDBMS. I mean, how the relationship is created, how to do that, and all that we will understand when we progress with the time. Okay, I mean, when we progress with the training. So that's pretty much on a RDBMS is all about. Okay, see, this is all the concept which is introduced by a scientist called as an EF card. I mean, he defined the different rules to store the data, and then these RDBMS products have actually evolved, right? So when you actually look at the different type of databases, what you see in the real market, uh, I mean, it can be any application, right? So suppose let's say if you want to store the data about the different type of customers and the transactions, what they're doing in a basically when you take about an example for a Bank of America, they have to store all their customer details and from which ATM they're withdrawing the money, from where they're actually transacting, how much amount, everything, all the details will be captured in the form of a database, right? So what I'm saying is a database basis plays a very important role in our day-to-day life applications what we use, right? So we'll come back to that, right? So when you look at the different type of databases which are available in the market, right, from the different vendors, you see a lot of IT companies, product companies which are there in the world now, right? So different companies have come up with their own databases, right? So if you see a traditional databases like Oracle, right? So this is from an Oracle corporation. I mean, when you look at another database called as a MS SQL server, which is from Microsoft, right? You have another database called as a DB2, which is from an IBM. You know, you have other database from Sybase, which is from an SAP. SAP has actually acquired this company, right? So you have from Amazon, you have a database called as a Amazon Redshift, right? Similarly, you have open source databases like MySQL, and you have something called as a PostgreSQL, right? PostgreSQL. Likewise, there are a wide variety of databases which are available from a different vendors. All all these databases store the data in the form of a table only. And in order to store the data in these databases, right? In order to read the data, store the data, manipulate the data, to do all these actions, we needed a language to communicate with these databases. So what language is going to help us to communicate with all these databases? That is nothing but a SQL. So SQL actually stands for a structured query language, right? So structured query language, which is called as an SQL, right? So this structured query language, basically it's a set of commands which we use to communicate with a database. SQL helps you to communicate with a database, right? So it helps you to communicate with a database. SQL is basically a set of commands which helps you to communicate with the database. So what type of actions that you can do on a database, right? So basically you can define the structure of the tables, right? You can add the data, you can update the data in the tables, you can delete the information from the tables, right? And then basically you can remove the tables, which is nothing but a drop the tables from the database. To do all these actions, SQL provides you the different set of commands to perform any action on these databases, right? So I mean, we will understand all those commands in detail, but I'll just give you on a high level. Whenever you want to define anything within the database, that is called as a DDL, which is called as a data a definition language, right? So data definition language, it helps you to define the tables and the different type of objects. So what are the commands under that data definition language is that create is to create the different objects within the database, alter is to modify them, drop is to remove from them. That is called as a DDL. So similarly, when you look at the DML, DML stands for a data manipulation language, right? So data manipulation language, which is called as, let's say, insert, right? Let's say update, and you have a delete. So insert, update, delete, which is nothing but the DML data man. Whenever you want to add the data, update the data, and delete it. Similarly, there are other commands as well, which I call it as DCL, data control language, right? So data control language. So which is to control the privileges between a one user to another user, which is called as a grant and revoke, right? And whenever you want to read the data from the tables, which is called as a DRL, DRL stands for a data retrieval language, right? So data retrieval language. Whenever you want to read the data from a tables, we use a command called as a select. Select helps you to read the data from one table or a multiple tables when you see. And there is another one called as a TCL, which is called as a transaction control language, right? So transaction control language commands, which is called as a TCL, which it is called as a commit, and then the a rollback is another the command what we have, commit and rollback. So this basically the different type of commands what you have. So we use all these commands to communicate with these databases, right? So to communicate with these databases, we use an SQL that is called as a structured query language. So SQL is going to be I mean, you can call it as a universal language to communicate with any of these databases. Without SQL, you can't do anything. I mean, let's say you're buying a Oracle product and you want to store the data, right? If you want to store the data, you need to use SQL. If you want to read the data, you need to use SQL. You want to manipulate the data, you need to use SQL. So SQL is nothing but a set of commands in a language which helps you to communicate with your databases in short. Okay, so these are all the different databases what we have. So when the RDBMS concept has actually evolved, they started storing the structured data. When you say structured data, which can be basically configured to store in the form of tables, that is, you can call it as a structured data. I mean, let me tell you, I mean, the data in nowadays, you know, if you have to understand the different type of data what we need to store for our information, right? Basically, uh, uh, data, right? Data is in the different forms, no? You can have a data in the basically in the tabular format, I mean, which is nothing but your XLS format or whatever, or it can be a CSV format or any delimited files. That is called as a structured data. Structured data. I mean, when you talk about the XML data, I mean, if you don't know about XML, you can probably Google it and understand how the XML file looks like. So those XML data is termed as a semi-structured data. XML, all that semi-structured data. I mean, when you say unstructured data is nothing but something which you have in a PDF file, or something which you see the review on a Facebook. I mean, Facebook data, or a Twitter data, right? Or maybe when you go and look at the log file, I mean, maybe the Windows error log, operating system error log data. So this is all your unstructured data, unstructured data. So your tables, I mean, your databases, whatever we are talking about, this can actually help you to store only the structured data. If you have semi-structured data, unstructured data, this data cannot be stored. I mean, you cannot really store this unstructured or semi-structured data into these databases. When the big data concept, I mean, when the huge volumes of data concept is actually evolved, then they wanted you know, the different type of databases or a different type of products where which can store even unstructured data also, which can store unstructured data also. I mean, suppose let's say if the Facebook has to store all that reviews, likes, everything, so the structured data is not possible. I mean, let's say if the Twitter has to store all the list of followers data, and at the same time the tweets data, who is tweeting it, who is liking it, who is retweeting it, all that unstructured data, if it has to store, these structured databases are not, I mean, it's basically this doesn't have a capability to store. When the people have I mean, when the organizations needed to store unstructured data, then they went in for an unstructured databases. I mean, the databases which will store the unstructured data. I mean, I call it as big data databases, right? So then I mean, slowly the products have evolved. I mean, Hadoop, I mean, which is nothing but a HDFS, Hadoop file system. This is one of the, you know, the open source product which stores your structured as well as a semi-structured, unstructured data in the form of a file system, right? And you have a products like HBase. I mean, HBase is, I mean, people say that HBase is one of the product used by Facebook. And there is another a database which is called as Neo4j, which is graphical database, and you have HBase, you know, Big Hive. Likewise, you have a wide variety of unstructured databases, something like Cassandra, I mean, Neo4j. These are all your big data, unstructured databases, which actually uses. So in order to communicate with these databases, we cannot use SQL. I mean, directly SQL cannot be used. I mean, you need an interpreters. Okay. So basically, to use, I mean, in order to communicate with Hadoop, we use something called as a MapReduce program, which is nothing but a Java program. And for communicating with a pig, we use a language called as a pig query language, right? So, I mean, it is called as a pigquel. And for interacting with a hive, I think HBase uses the I mean other type of this one, and then other type of SQL, CSQL, Cassandra SQL language. So likewise, these are all the big data databases. You know, when you actually step into ETL world these days, you probably even have to learn how these databases stores the data as well. I mean, this is all about your big data, big data databases. So when I say no SQL, I mean these databases, you don't need an SQL. That's why these are also called as a no SQL databases. I mean, all these databases are called as a SQL databases. Here we don't use SQL to communicate them. That's why we call it as a no SQL databases. And this one is called as a SQL databases. So these are all the different type of database. I mean, in order to store for any application, you probably have to use any one of these database to build any application, right? So I would like to hear from you if you have any questions so far on a different databases, a structured as well as an unstructured, what is SQL and what is no SQL database.
Can I ask you a question?
Yes, please go ahead.
Okay. Yeah. So is that the Oracle MS SQL until the post-grade SQL? This is the same thing. This is all under big data, or big data is whole different things?
I mean, you basically, these are all the databases which cannot be compared with big data. I mean, these are all only stores of structured data. If you ask me the question in a different way, okay, can it store the big data, or maybe I mean, when you say big data, it's not about only the volume, it's a variety of data, right? So it cannot store that XML or a PDF files, or it cannot store your log files data, or maybe a sensor data. It cannot store. But Hadoop, HBase, and all these can store.
Okay, so Oracle, all these are basically database structured data, and big data is unstructured data, correct?
Yes, yes, unstructured data, mostly used for unstructured data. Yes.
And Hadoop to Cassandra, this is their language for big data.
No, these are all the different type of databases. I mean, Cassandra is one database which can store unstructured data. Hive is one database which can store the unstructured data. Pig is one. Neo4j is one. HBase, Hadoop. Just like you have Oracle, MySQL, Amazon Redshift, like same way, you have even in big data, you have a wide variety of databases which
So
will store unstructured data.
Hadoop to Cassandra, they are under big data. They are part of them.
Yes, true.
Okay. And second question about SQL, and after the DDL to TCL, this is all the part of the SQL?
Yes, these are all under SQL.
Under SQL. Okay, got it.
Right.
Karthik, can I ask you a question?
Yes, please go ahead, I think.
Yeah, it's about NoSQL. Since I don't have any idea about NoSQL. Can you please a little bit elaborate about NoSQL? How it stands, and what is the difference between the?
See, what is SQL versus NoSQL is that all structured databases, whatever we talked about, your Oracle, SQL Server, DB2, everything, if you have to communicate with these databases, you need to use SQL to communicate. That's why these databases are called as a SQL databases. When you want to communicate with these big data databases, SQL is not a qualified language to communicate with these databases. That's why, since we are not using SQL to communicate with these databases, these are termed as a NoSQL databases. That's it. NoSQL means you're not using SQL to communicate them. That's why it is called as a NoSQL. That's it.
Okay. But still, we can use SQL for those Hadoop, HBase, and all those databases, right?
No, I mean, there are tools actually, so suppose, let's say if the Facebook and all, there is a tool called as an Impala. If you write an SQL query, it will convert into a Hive query, something like that. But there are tools, but these databases don't understand SQL. If you say DDL command, it will not understand DDL command. It will not understand DML command. So if you have to communicate with Hadoop, you must write a MapReduce program or advanced MapReduce program. Or if you want to communicate with Cassandra, you must write a Cassandra SQL language, CSQL. So it will not understand actual SQL, what I mean by DML, DDL, but these are slightly different. You can't say that it is completely new, but these are slightly different, but not
Okay, thank
exact
you.
SQL.
Thank you. I got it. Thank you.
Okay. So we can say SQL is for the structured database and NoSQL for big data, correct?
Yeah. So no SQL again, don't term it as no SQL as a language. Why it is called as a no SQL is because you're not using SQL. That's why it is called as no SQL. This is not a language. I can't say that no SQL is a language.
Oh,
It's
okay.
just no SQL database. That's it. But if you see, that's why when I say this Hive, Cassandra, and all, I'm not saying we are using no SQL. We will use a different languages. For interacting with Pig, we use Pig query language. For interacting with Hive, we use Hive query language. For interacting with HBase, you use a different language. CSQL for interacting with Cassandra. So it is not SQL. It is a form of an SQL, but it is not an exact SQL.
Okay.
And again, don't think that no SQL is again a language. It's not SQL. I mean, you can also call it as no SQL, no to SQL, not SQL. That's something like that. That's it. Right. Any other questions?
Nope.
All right. So I mean, you can hope pace is fine. I'm not going fast. You guys are good.
Yeah,
Muhammad,
that's okay.
pace is fine, right?
Yes, Karthik, but are we going to get a recording?
Yeah, recording is always there.
Okay, thanks.
And you're gonna send us all these notes in email or something, correct?
Yes, I do.
Thank you.
Right, I'm going on. I'm moving on further. Okay. So now let's talk about a real world applications, what we see on a day-to-day basis, right? Okay, when you look at what is OLTP, um, OLTP is nothing but a online transaction processing system. On a day-to-day our life, we use a lot of OLTP systems. I mean, transaction is nothing but in a technical terms, a transaction is nothing but where you're adding the data, deleting a data, or updating a data, that is said to be a transaction. Wherever you are manipulating a data, that is said to be a transaction. So why these applications are called as an online transaction processing system? Because there will be a frequent transactions which will be happening. When I say frequent transactions, it is nothing but a frequent inserts, frequent updates, frequent deletes will be happening on this system. That's why we call it as an OLTP. As I said, we use a lot of applications on a day-to-day basis. I mean, and I say a lot, we use more applications on a day-to-day basis about these OLTP. Okay, let me give you an example. Okay, best example is your e-commerce applications, whatever you use on your daily life. Okay, something like Amazon. If you want to book a phone or if you want to book any product, right? So Amazon.com is one of the example for your transactional system. I mean, anything like eBay is your transactional system. Alibaba, I'm not sure if it is there in the US. That is also one of the e-commerce company. So these are all any online purchasing website that you're logging in. All e-commerce applications are transactional processing application. So what is the transaction here in an e-commerce application? In an e-commerce application, booking any product, booking any product, in our technical terms, we call it as an order. Order is a transaction. Once you book the product or add to a cart, you make the payment. That is nothing but a transaction. So it's a payment transaction. right? And once you make the payment, vendor will actually ship the product. That is nothing but a shipment. That is nothing but a transaction, right? And in case if you don't like a product, you return that product back to the vendor or Amazon. So returning the product is a transaction, right? So a transaction is nothing but, in a technical term, where some amount of manipulation of data is happening on the system. That is a transaction. Okay. So let me give you another example which you use on a day-to-day basis. Let's say ATM withdrawal, or maybe a credit card transaction, what you term, wherever you go and swipe your credit card and all that, right? So when you look at the ATM, what is transaction? Withdrawal of money is basically an ATM. Basically a transaction, right? Or you want to deposit the money into an ATM or into your savings account. That is said to be a transaction. Um, so you want to transfer the funds from using an ATM from one account to other account. That is said to be a transaction, right? So these are all a different transactions what you see on a day-to-day basis. This is also one of the OLTP, right? And basically, you have some of the online payment applications, right? What you use. If I say online payment applications, right? Maybe your utility bills, where you go and pay a electricity bill online, right? Or you go and pay your water bill online, right? Or maybe you go and pay your credit card bill by using something that is also said to be a transaction. So there are wide variety of applications what you use on a day-to-day basis. But in real time, okay, what kind of applications the organizations use? Organizations, if I say financial organizations or telecom organizations, or it could be the a generic IT organizations. What kind of applications they use on a they use to maintain or run their operations, right? OLTP, you can also call it as it's an operational application. It's to run your day-to-day operations. Amazon.com application is something which is used to run their business on a day-to-day basis, right? So let me give you some of the applications which are used by the different organizations. If you talk about let's say IT organizations, to manage their all human resource operations, right? To When I say human resource, what does a human resource operation includes? Employee appraisal process, employee payroll process, the employee reimbursement process, and then employee recruitment process. All these comes under the human resource. Okay, a company like Google or a company like Apple, if they want to keep track of complete list of their human resource activities, what application they use? They use a HRMS applications, right? Let me give you a sample examples for a HRMS application. A PeopleSoft is one of the HRMS application. SAP, a success factors is one of the HRMS application, right? You can call it as Workday is one of the, these are all the different products which I'm giving you. uh, Oracle HRMS, which is cloud or whatever, these are all a different human resource products which are available. Any one of these products will be used by your Google, or any one of these products will be used to manage their human resource application. So why I'm actually talking about all these is because whenever you want to read the data using an ETL, these are all becomes your source systems. Okay, that's why you need to know what are all the different products used within an organization. So Oracle HRMS, SAP Success Factors, PeopleSoft, Workday, these are all your human resource management applications which they use, right? So in order to um, basically take care of your sales process within the organization, right? um, Sales process is completely a CRM applications which we call, so which is nothing but sales or a CRM applications. If you see, there are different CRM applications. If you look at, let's say, Microsoft CRM or Oracle CRM or you have Salesforce.com, which is a world #1 CRM, Salesforce CRM, which is to manage their customers, their sales process, everything. Salesforce CRM, right? And then likewise, you have a Zoho CRM. These are all the a different type of CRM applications which are used for the sales process. I mean, whenever you want to manage your order management and invoices, orders and the invoicing process. Suppose, let's say if Amazon has to take care of the customer orders, invoicing process, vendor payments, everything, they need to have they need to use a separate applications, right? They use SAP ECC or Oracle EBS. I mean, these terms might be very new to you, but eventually when you get a time, try and explore on all these products. This gives you a understanding about OLTP applications which are used by the different organizations, SAP ECC, Oracle EBS, and maybe sometimes they used to use even mainframes before all that. That becomes your orders and invoicing management applications. Likewise, if you have to take care of your manufacturing module or demand planning, so there will be a wide variety of applications which will be used in an organization, right? So if you talk about maybe a banking products which is to take care of your core banking, sorry, which is to take care of your I mean retail banking, I mean investment banking, all as again different type of banking, right? So they use a products like banks, FlexiCube, right? To take care of your savings account, checking account, credit card management, loans management. So these are all the direct products, okay? Pinnacle, and there is another product which starts with T. I don't remember that. So to take care of your banking, I mean, everything is related to banking will taken care by these of the products. So likewise, you'll have a wide variety of transactional systems which are used by an organization to manage that, to manage human resource you want, to manage sales you want, basically to take care of your even administration, to take care of your tax filing, finance department. While I'll probably use that. So wide variety of transactional systems will be available, and all these transactional systems basically used for a day-to-day operations. To run any organization, to run your day-to-day operations, you need, right? uh, to I mean day-to-day operations, you basically need um, a transactional system, that is your OLTP, online transaction, to only to run day-to-day operations. We don't analyze the data on top of your OLTP system, means we don't generate any reports. It is to take care of your day-to-day operations. If Apple has to run their HRMS operations on a day-to-day basis, they may need any one of the product. If Amazon have to run their order and invoicing process, they may need one of the product. So these are used for a day-to-day operations. And basically one characteristics that you also need to understand, OLTP systems always stores most recent data and no history. We'll come back to this. Just understand that it will always stores only the recent data. No historical data will be stored in a transactional application. So this is your OLTP is all about. I mean, on a day-to-day basis, we also use a lot of, I mean, if you actually pick up and then you just want to book any donut, basically you probably use the transactional a transactional application. You take an ATM, or you basically pay for any cab using an online payment application. So all these comes under the a transactional application, right? So any questions here in understanding a transactional applications?
One question, Karthik. This you're telling that human resource sales, CRM, all these are products, right? So can you tell those products like as a tool, or is you put it under category like database, or what? What is it? Because we have been
Yeah, we can
listening
call
to
them as an applications. I mean, rather than terming them as tools, we can probably call them as an applications, Microsoft CRM application, Salesforce application, or SAP SuccessFactor application, all that. I mean, these are ultimately the tools only, but we term them as an applications because it is
Application.
used more at the enterprise level. Yeah.
Okay, thank you.
What is CRM stand for?
Customer relationship management, to take care of your customer. Whenever you want to, when a customer, suppose, let's say, let me give you a life cycle of a CRM. Okay. I mean, this may be very important for your future learning. Okay. So a CRM is nothing but, suppose, let's say, think of tech classes itself, right? Basically, whoever inquires about the training, they need to store it. They need to call them. They need to understand what is their expectation, convert them, and then, basically provide the interested quote, and then probably eventually they have to close that order. So something like that. So CRM is to manage complete customer management. That is said to be a CRM. Customer relationship management stands for a CRM. That's it,
So
right?
is that OLTP is also some kind of database?
No, it's application. I mean,
It's
it's not a
application.
database. I mean, when I say application, application uses the database
Okay.
to build. I mean, suppose, let's say, if I have to build library management system, okay, library management system, I call it as an application. But in turn, application uses maybe a SQL server database for storing the books, ISBN codes, who is taking that book, who is returning that book, how many books are available, all that. To do all these storage activity, we use a database. So when I say a PeopleSoft is an application, right? So basically, a PeopleSoft intern to store the employees data, or to store the payslips data, and to store the appraisal data, it uses the database. That's how it is. Okay, right, are we clear here?
Yeah,
Yes.
got it. Thank you, clear.
Yeah, let's move on. And right, so let's move on and understand about what is a data warehouse. Okay, see, all these OLTP applications uses, these are used for your day-to-day operations. Okay, these are not used for your analytical purpose. When I say analytical purpose, suppose, let's say, if I want to know, Amazon Jeff Bezos want to, basically want to understand what is the total revenue generated across all the countries, maybe India, US, and then Mexico, Brazil, something like that. He wants to run a report and understand what is the total, basically the total revenue that is generated by each country. That may not be answered by, I mean, that question may not be answered by your OLTP. Suppose if I want to know top 10 best sales reps in US, I mean, this OLTP may not answer that question. So in order to analyze the data and all that, for that we need a data warehouse. So data warehouse is nothing but a database. Okay, I mean, it's nothing but a database which stores the data, which stores the analytical data. So let's call it as data warehouse is nothing but a collection of data from different OLTP systems, collection of data from different OLTP systems, storing it in a centralized database and used for analysis purpose. Used for analysis purpose, that is called as a data warehouse, what we see. So collection of data from a different transactional systems, which is used for analyzing purpose, that's called as a data warehouse. Data warehouse is also called as OLAP system. OLAP stands for a online analytical processing system. So OLAP is nothing but an application which is used for analyzing the data. Online application, basically the processing system, which is called as a OLAP or a data warehouse. It's one and the same. Okay, so let's understand now. I mean, I'm saying OLAP is nothing but it's a data from data which is collected from a different transactional system, and we are storing it in a centralized database. That is called as your data warehouse. Okay, so a data warehouse is something. Whenever I want to build a data warehouse, I can choose any one of the database as my data warehouse. I mean, I can choose Oracle as my data warehouse, Oracle database as my data warehouse, with a sense all OLAP data I'm storing in Oracle, or I can choose MS SQL Server as my data warehouse, right? Or I may choose completely Hadoop itself as my data warehouse, or probably Amazon Redshift, I can use it as my data warehouse. So likewise, a data warehouse is nothing but a database. We can use any one of the database as our data warehouse. So data warehouse is not a technology. A data warehouse is just a concept, which data warehouse is just a concept which is actually used for analyzing the data. So that is termed as a OLAP. I mean, I can use any one of the structured database and unstructured database as my data warehouse for analyzing the data. Okay, let's now understand what is ETL and where does an ETL comes into picture and what is a BI. I want you to concentrate here. So I'm going to take up the simple example by taking one organization. Okay, I mean let's take Bank of America. Okay, so Bank of America, for taking care of their, let's say, the savings account, right, or a checking account, maybe their credit card transactions, and there may be corporate accounts. I mean, let's say corporate accounts, when I say to take care of a commercial accounts and everything, let's say they're using one application which is called as maybe a FlexiCube, which is used for completely the core banking operations. Core banking means a credit card, savings account, and all that, right? So every day on this core banking application, there may be a hundreds of millions of transactions. It may be happening. I mean, millions of transactions, right? I mean, there may be a million customers probably for Bank of America. If each of them will do only one transaction per day, it is going to be a million transaction which will happen on your core banking system. So this is basically to store all your customer related information, their transactions, their balances, their withdrawals, everything. So this is used for a core banking system. Let's say Bank of America does also offer some mortgage loans as well as a gold loans, or maybe the auto loans, everything. So to take care of their all the complete loan management, I mean to take care of the loan processing and all, let's assume that they're using another other application which is a loan management application to take care of their auto loans, everything. So this is another application which stores only the data about loans, right? And similarly, for storing all their employees information, their appraisal, all that, assume that they're using SAP success factors, right? SAP success factors is completely used by, I mean, basically for um, their learning as well as a payroll, and basically to fill the timesheets of the employees, everything. They have another thing which is basically this one. So therefore, their investment banking. Let's say they're also into, assume that they're also into investment banking. They're using another application. So if you see data of an organization, I mean, let's say a CRM, I mean, they're also using a Salesforce to manage their complete list of customers. See, when you look at this example, what I'm actually talking about, in an organization, there will be a different departments, and for to make each department to function, each department might use a different type of applications, right? So your sales department is using a Salesforce, your HRMS department is using a success factor, your loans department is using one application, and your banking department is using another application. From this, if you actually understand, your data, operational data, is actually distributed across the multiple different applications within an organization, right? My data is actually spread across the different applications. If I have to understand how many credit card customers who also owns the, who also who would have also taken a loans as well. First, I need to query this application. First I need to read the data from this application, then go here, read the data of all the customers, take the intersection of it, right? Right? If you guys understand my question. So my question is, I want to understand the customers who defaulted the credit card payments as well as the loan payments. Okay. I can't basically analyze that just by a simple report. All I need to do is first I need to go and query the list of defaulters in the credit card department and the list of defaulters in the loan, and then take the intersection of that data, which will answer my question, right? So what I'm trying to say here is, transactional systems are not suitable for your analysis purpose because your data is spread across the multiple different applications, and you cannot answer them with a single query, right? So that is why what we are doing is to make your analytical process more simpler, right? What we are doing is we are actually integrating the data from all these transactional applications into a centralized database or an application, which we call it as a OLAP or a data warehouse. As I said, whenever I say DWH, it's nothing but a data warehouse. So we integrate the data from all these applications into data warehouse. And here we store the data in the form of a tables again, which we term them as dimension tables and fact tables. We will understand that later point of time. The process of integrating a data from these transactional systems into a centralized database, or moving the data from your transactional system to this, is termed as an ETL. Your ETL stands for extraction of data. Extraction is nothing but reading the data, right? Reading the data. And you have something called as a transformation of a data. Transformation is nothing but modifying a data or applying a different rules, cleaning the data, cleansing the data, removing the erroneous data. All that comes under the transformation. And the next one is called as a load. Load is nothing but you're inserting a data or updating a data. That's called as your ETL. Okay, ETL stands for extraction, transformation, and load. The process of integrating a data or moving a data from your transactional application into a data warehouse is generally termed as an ETL. So to do this activity, to integrate the data from all these transactions into a data warehouse, we have a wide variety of ETL tools which are available in the market. That is, one of that tool is called as your Informatica Power Center. One of the ETL tool is called as an Informatica Power Center, and the other tool, you have the tools like Data Stage, and you have a tool like Ab Initio, and you have something called as an ODI. ODI stands for Oracle Data Integrator, Oracle Data Integrator, and you have something called as a Talent and Pentaho. So likewise, there are a wide variety of ETL tools which are available again. All these ETL tools helps you to either to migrate the data from one application to another application, or it helps you to integrate the data into a data warehouse. So it is used for two purposes, either for migration of data or for integrating a data from your integration of data from your wide variety of applications. That is called as a ETL. So we are going to learn about Informatica Power Center in this training, how to integrate the data from your different transactional systems into a data warehouse. That is more on a ETL front, right? So what is BI? Now I have loaded the data here. What is the purpose of it? Why do I get the data from my transactional system here? Why do what is the purpose of loading a data into a data warehouse? So this is used for a analysis purpose. As I said, to understand how your business is doing, your management, in an organization, the management might need a lot of questions to understand how the business is doing, right? So in order to understand how I'm growing, whether I'm making profits or not, where I'm actually losing the money, at what rate I'm actually growing, all that kind of a questions will be answered by your data warehouse. To do that, again, you need a tool to do that. That is nothing but a BI. So what does a BI does, or what does a business intelligence tools does? Business intelligence tools, what it does is it actually reads the data from your data warehouse and represents the data in the form of a report. A report is something, okay, let me give you an example for a report. A report is something, a data representation basically, either in the form of a bar graph, um, a pie chart, or maybe a line graph, right? So these are all the, I mean, you can represent the data in a different formats, right? So if you actually look at it, these are all the different ways of data. I mean, you can represent basically the different type of charts, okay? A scatter plot, a bar, pie chart, donut. I mean, you can represent the data easiest way to understand the data by the business users. So BI tools, what it does is it reads the data, represents the data in the different formats. Okay, what kind of questions are generally answered by your data warehouse? Suppose, let's say, if I have to understand revenue by each country, right? If I have to understand, let's say, the top 10 sales reps in California who are selling my products, right? Or maybe uh, the growth percentage, like how did I grow from last year to this year? I mean, if I have to understand the previous year revenue versus current revenue, I mean, previous versus current metrics when you want to do that, right? So all these kind of analysis needed by the higher authorities in the organization. They need to understand on a day-to-day basis how the company is actually growing. So to understand that, we need a BI tools. So there are, again, BI tools are called as a OLAP tools or reporting tools in a layman terms. So there are different reporting tools. Again, what you see, a Tableau, ClickView, Cognos, right? OBIE, business objects, right? BO, which I'm calling it as business objects. Likewise, you have a wide variety of BI tools which are available, and those BI tools will help you to analyze the data and understand the data. So this is pretty much about what is a BI and what is an ETL. So this course specifically focuses on how Informatica Power Center or an Informatica Cloud can integrate the data from the wide variety of transactional systems into a database that we are going to talk about. So that is your ETL versus this. Okay. So quickly, any questions here?
Is it ETL works as a same as a SQL?
I mean, SQL uh, may
Almost
not
same
have
thing.
all the capabilities.
Uh-huh.
SQL may not have all the capabilities like an ETL tool. It has even very rich features. SQL can interact with only with the database. I mean, database tables. But your ETL tools like Informatica and all, it can interact directly with application, or it can interact with XML files, or it can interact with flat files. All that can happen. But SQL cannot read the data from an XML, or SQL cannot read the data from your flat file. That is not happens. But ETL is more sophisticated and the to easiest way to read the data. But I mean, using an SQL also, you can do the similar kind of an activities, but SQL has a lot of limitations, whereas an ETL has a rich features to do that.
Okay.
It's one of the tool, that's it. But eventually, yes, your catch is correct. Eventually, ETL uses an SQL for interacting with the databases. For that reason only, we need SQL also to learn.
Okay.
So if I have to make my Informatica to read the data from SAP SuccessFactors, my Informatica might use SQL to read the data from SAP SuccessFactor, or it may use a different approach as well. So, but eventually ETL uses a select statement to read the data. ETL uses insert statement to add the data in your warehouse. So ETL uses an SQL, but SQL itself is not an ETL.
Okay. And with all these ETL tools, which one is more like in the market right now? Which one is more popular?
So Informatica Power Center is being the leader from last 15 years. I mean, you can also go and check the Gartner report, Forrester report, and everything. I mean, you could say top ETL tools, maybe ETL tools in market 2009. You can look at the Gartner's report. So if you see, Informatica is on the top tools for your if you want to even check Gartner report, basically an image. If something is there, you can, I mean, Gartner report. I mean, Informatica is being the leader basically from last 15 years, you could say. So if you see, data stage is from IBM. SAP has their own tool, and Talent is one. Oracle is data integration. If you see, the Informatica is very far compared to this. And if you look at the other things like ab initio and all, this comes under the, and that's yeah, you have from Microsoft also ETL tools like SSIS, SSAS and all that. Yeah, but those are all not basically anywhere competitive to Informatica. Informatica has more than 40 to 50% of the market, and all Fortune 100 companies uses everything. You can whatnot. Most of the companies uses Informatica.
What is Spark actually when we go for big data or ETL? I see there's a lot of terms in Spark. What is that one?
See, the Spark, I think Spark acts as an ETL if I'm not wrong. I mean, what I read, basically Spark is basically an ETL. Is Spark an ETL? Yeah. So Spark probably helps you to read the data between the mm, uh, within a Hadoop system. I mean, if I call it directly, basically Apache Spark. Can Spark is used for ETL? Yes, with the big data, a Spark acts as an ETL in between.
So is another tool or is something
Yeah,
more
it's
different?
one of the tool. It's one of the tool. I mean, we'll understand the architectures. If you have to interact with the big data, other formats of the data, some of the traditional tools are not. I mean, cannot communicate with your big data technologies. That time, you can use a Spark program to write an ETL.
Okay, and is it ETL and Hadoop? And what is the relation between ETL and Hadoop?
See, here, here what we are doing is we are reading a data from your transactional system and loading the data into OLAP. I'm saying OLAP can be an Oracle, right? So suppose, let's say if you're using Hadoop itself as a data warehouse, okay? I can read the data from transactional system and load into an Hadoop. Hadoop and ETL are different. Hadoop is more like a database. ETL is a middleware which can actually integrate the data. It's a middleware between the applications. Hadoop and ETL both are not same. Hadoop is just, I mean, you can just consider that as one of the database, which can store the unstructured data. That's it. But ETL can read the data from Hadoop and load the data into Hadoop because it's just a database, right? That's how it is.
We are not learning anything in BI in this session, correct?
No, no. we're not learning, but extensively we will learn more on the ETL side. Yes.
And can you also explain what's the schedule and the whole training and how is that going to work?
Yeah. So still I'm not really gone on to completely what we learn and what we're going to learn. I mean, if you're done with these questions, probably I'll explain you what we're going to learn as part of this training.
Yeah, I'm okay. Is anyone else?
Right. Any other questions from anyone? Mohammed, Atik?
Yeah, just are we going to cover of SQL? Karthik, that's my only
Yes,
question.
yes.
Okay, cool. Because there are a lot of questions nowadays asking by interviewer about SQL.
Oh,
That's
okay.
correct. Yeah.
All right. So what we are going to learn as part of this training is that first we will learn SQL for, let's say, about some 10 classes. We will try to confine ourselves into 10 classes. And I also want to give you a little bit of information about the programming, that is your PLSQL, maybe about some 3 to 4 classes I would like to spend. And basically the next, we are going to understand about the data warehousing concepts. All that will be mostly will be spending another 2 classes. I mean, whenever I say class, it's nothing but an hour long, okay? And we'll talk about the data modeling and all that. So this is maybe a 2 to 3 hours, depending upon the stretch of the questions what we have. And once you're done with that, then we'll spend time on Informatica Power Center, which extensively, right from the beginning, we will learn completely on Informatica Power Center, what it is and all. We will spend nearly 30 hours to do Informatica Power Center. I also want you guys to learn more on Unix because it is needed. For Unix shell scripting and all, I'll probably spend, let's say, 2 hours again, right? Then I also want to give you the more information on Informatica Cloud as well. I mean, depending upon you guys' interest and everything. So I would like to spend minimum 5 hours on this, because nowadays, I mean, you'll understand what is difference between a on-premise Informatica versus Informatica Cloud. I would like to give that. So this is what we are going to learn as part of the training at a high level. I mean, I've given you the contents. More than what is being there in the contents, we are going to learn further, right? This is what we are going to do as part of this training, right?
So is that the cloud means like AWS, Azure, all
Yes.
this comes with that? Okay.
AWS, yeah. See, the clouds are of different types. Okay, you have software as a service, infrastructure as a service, platform as a service. AWS, Microsoft Azure, Google Bigtable, Netflix, not Netflix, NetSuite, all these are provides you infrastructure as a service, IaaS. They give you complete machine itself in the cloud where you can use that. That is termed as a infrastructure as a service. I mean, this is very important. I think you probably can understand and explore more. Okay, so there is 3 types of cloud offerings. Okay, SaaS, software as a service. One more thing is PaaS, platform as a service. IaaS, infrastructure as a service. So infrastructure as a service means in the cloud, they're going to give you a server itself. You can deploy your own application or a database or anything on that, and then you can start using it. So when you talk about this AWS or Azure and maybe the NetSuite, all these comes under the IaaS, infrastructure as a service. And there are certain things like software as a service. Okay, um, maybe you can call it as, let's say, Tableau Cloud. So this basically they will give you a software or a reporting software which is called as which runs in a cloud and it can be connected to anything. So that is software as a service. When you say PaaS, platform as a service, uh, you call it as maybe something like, I mean, I'm giving you a lot of examples here. Heroku, and if you Salesforce is also one of the a platform as a service. You can build your own application on that platform and then use it. And then you can use Service Max or Service something, yeah, Service Max or whatever. That is also platform as a service. So basically, the cloud offerings are many. Some will offer as a software as a service, a platform as a service, and infrastructure as a service. It's yeah, you can compare Informatica Cloud as one of the cloud offerings, but it is not same as AWS and Azure. It's different. That's it, right? So Informatica Cloud, you can, in a simple terms, you can call it as software as a service. I mean, even though Informatica even projects themselves as a IaaS, basically infrastructure as a service as well. So if you actually want to learn Informatica Cloud, right? So yeah, we will slowly anyway explore it. Now they are calling it as Informatica Intelligence Cloud Platform, IICS. IICS they call Intelligence Cloud Platform or something. So we'll see that how that's going to work and everything, right?
And it's going to using Unix system or VM system or something like that when you go in Informatica clouds.
Yes, we use a Unix operating system only, where Informatica is actually being set in that, and then it uses that. Okay, we use that.
We don't need to learn any specific language such as Python or R or Java something for this ETL system or no?
Yes. So you don't need to learn Python as such, because ETL uses only SQL. Anyway we are learning SQL. What is needed? We don't need Python for Informatica, but I mean, you can even call Python script. Basically, that's all.
Okay.
Karthik, I have a question regarding this PL SQL, which you're going to cover like for 2 lectures. And it's good, because I had a interview as a data test analytic, and then they asked me that everything they're going to convert from SQL Server to PL SQL. So they said now it's getting very popular. So they're saying, since we'll be converting everything to in that, so they want to know how much I know PL SQL.
Okay, we'll see. No problem. Right.
So PL SQL is another language, correct?
I mean, it's an extension to SQL. Yeah, we will learn that what it is.
Okay. What is the time for daily meeting or?
No, and this is
Or how long
probably,
is going?
if you guys are comfortable, we can prepone a half an hour. Otherwise, we can have at the same time 8:30.
8:30. And is it all 7 days or how many days?
No, I think we'll have it from Monday to Thursday or Friday. That's it.
Okay. No weekend class, or can we include weekend and go in weekdays off or something, or whole 7 days? I don't know. Is that okay for everyone?
No, I think we'll have it on only weekdays, because weekends I may be traveling sometimes, so I may not be here. I mean,
Okay.
right. So, any other questions from anyone?
No, everything pretty much good. Just to install, I mean, just would you help? You could help me, right? Just I'm getting my tool today. I mean, the laptop today. So.
Yeah, we can do that.
Okay.
We don't need to install any tools or anything right now, correct?
No, I mean, there are certain things like you'll eventually learn it. For practicing some certain things on the Informatica, you need to install. That you have to install it in your system to do that. If it is a cloud, you don't need to install anything. But when you want to learn on-premise things, yes, you need to install certain things. That we will discuss what to be installed and everything.
All right.
All right, so that's pretty much what I have for today. Mohammed, I didn't hear you. I hope you're all good. I don't know. Okay. All right then. Thank you. So I'm just stopping it for now. So we'll meet tomorrow to
This conference will now be recorded.
tomorrow we'll meet to discuss the first thing. That is going to be your SQL.
Okay. So it'll be 8:30 Pacific time. Right.
Yeah, it's the same. Right.
Okay.
Okay. Thank you. Thank you.
Thank you.
I'm stopping it for now. Thanks.
Thank you. Baba, watch.